Good morning. Today we are going to talk about equations. This is our starter activity. You have to work out how much each object weighs. Our objects here are the strawberry and the snail. I will leave it for you to think of it once you receive your PowerPoint presentation. As I said, today we are going to talk about equations, which is part of algebra. We have other parts like expressions and like formulas, but today we are going to talk about equations. In our learning objective, today we are going to be able to solve one-step and two-step equations. What do I mean by one-step equations? They are equations that can be solved in one step only. Examples for these equations are like the following: x plus 5 equals 14, x minus 5 equals 14, 4x equals 24, x over 3 equals 4. As you all know, and as we discussed before, whenever we write 4x, it means multiplication. And whenever I write it as a fraction, it means division. This is how we represent multiplication and division in algebraic expressions and equations, while for addition and subtraction can be written directly. So these are the examples that we are going to work on to show you how to solve each one of these algebraic equations. I'm going to start with the first one. I want you to think of algebraic equations as a chain. In order to find the missing part of that chain, you have to solve the other parts. We have to find the value of x. A lot of you might say it's so easy, x equals 9. We can do that mentally, but the main purpose of today's lesson, not to find the answer mentally, is while the main purpose is to know the steps of solving any equation. In order to find the value of x, we need it to be alone on this side. These are two different sides. I want you to think of them as the hands of a scale. This scale should be balanced. Why? Because we have an equal sign. So in order to keep that balance, anything that you do on this side, you should do the same for the other side. If I want x, I will cover it. What do I have to do with the addition in here? We have to do the opposite operation. So if we have plus 5, we have to say minus 5. And as I said, if we do anything for this side, we have to do the same for the other side. So if you subtracted 5 from this side, you have to subtract 5 also from the other side. 5 minus 5, they are going to be crossed. What do we have from this side? It's only x. X equals 14 minus 5, it's 9. This is how we solve it. Let's move to the other example. We have here x minus 5, which equals 14. Again, I want x, so I'm going to cover it. I need to think of the operation that we can do for both sides. I need to get rid of the subtraction in here. How do we get rid of it? By doing the opposite operation. So add 5, add 5. We have to do the same for both sides. I will cross these out. What do we have on this side? X equals what? Equals 19. Okay? I'm going to move to the next example. In here, what is the operation that we have? It's multiplication. In order to get rid of multiplication, what do we have to do? Opposite operation, which is division. I have to divide. So I will divide both sides by 4. And always you have to think of the number that is next or attached to the variable. If it's addition, subtraction, multiplication, division, so you have to think of the operation that you have on this side. So I'm going to divide both sides by 4. Once you divide, what do you have left in here? It's x, and 24 divided by 4, it's 6. Let's move to the next example. In the next example, it's x over 3 equals 4. What is this operation? This is division. As I said before, we represent division as a fraction. What is the opposite operation of division? It's multiplication. So I need to multiply both sides by 3. Since it's divided by 3, I need to multiply both sides by 3. Once you multiply 3 times x over 3, it's like you have 3 over 1, and these both are going to be crossed out. So what do you have left from here? It's x equals 4 times 3 equals 12. In each one of these equations, please make sure that you show your steps. I don't want you to find the final answer directly. Now we're going to move to two-step equations. Two-step equations, they're equations that can be solved with 2 steps. So these are the following examples. 5x minus 2 equals 18. 2x plus 1 equals 5. 16 minus 2x equals 12. We're going to work on these equations. First one, 5x minus 2 equals 18. I want to explain a very important thing. In solving two-step equations, you have to get rid of everything around x. We have 2 operations. We have multiplication and we have subtraction. As I said before, thinking of equations as a chain in order to find the missing part, you have to get rid of the easier operation. We used to work based on BODMAS, brackets of multiplication, division, addition, and subtraction. In here, we're going to do the opposite. We're not going to start with the multiplication, then we will move to subtraction. I need to start with the easier one, which is subtraction. Then I will move to multiplication. In order to do that, I need to get rid of the opposite operation. I will cover x. What do we have around x? So we need to add 2 to both sides. So this is step number 1. Once we do that, we have 5x equals 20. Is it done? No. We have another step. I don't want 5x. I need x. So in order to do that, I have to think. What is the operation that we have in here? It's multiplication. In order to get rid of multiplication, we have to divide. So we divide by 5. We divide by 5. So x equals 4. As you can see, we solve that equation using 2 steps. Please be careful. Again, whenever you have multiplication and addition, multiplication, subtraction, division and addition, division and subtraction, start with the easier one. This is our next example. We have multiplication and we have addition. Now, what do we have to do? We have to get rid of what first? We have to get rid of the addition by doing the opposite operation. Subtract 1, subtract 1. 2 x. So this is our first step. 2x equals what? 4. 5 minus 1 equals 4. Now, did we finish? No, I need x, not 2x. How do we get rid of this? This is multiplication. So what's the opposite? Division. Divide by 2, divide by 2. So x equals 2. So this is the second step. This is called two-step equation. For the third example, there is a small difference in here that we're going to use multiplying and dividing integers that we took at the beginning of this year. You have to remember the rules. Whenever we multiply any two positive numbers, so 1 times 3 equals 3. These are two positive integers. So the answer is positive. If I said minus 2 times minus 4, it equals 8. If you're multiplying two negative integers, the answer is positive. If you need to multiply one positive, which is, let's say, 2 times minus 1, the answer is going to be negative. Negative 2. So, as you can see, multiplying two positive integers will give you a positive integer. Multiplying two negative will give you a positive. Multiplying one positive and one negative will give you a negative. And the same for the division. If you are dividing 3 divided by 1, it equals 3. Negative 6 divided by negative 2, it's 3. Negative 2 divided by 1, it's negative 2. Using these rules, I'm going to solve the following. We have this equation. 16 minus 2x equals 12. As I said, we have to get rid of the numbers first. So minus 16 and minus 16. We can't get rid of the 2x now. We will cross them out. We have minus 2x or negative 2x equals what? 12 minus 16, as you remember at the beginning of this year, whenever you're adding one positive and one negative, the answer, you have to subtract and get the sign of the greater number. 16 minus 12, it's 4, and 16 is greater, so it's negative 4. Now, we have to get rid of this number. I'm not going to think of it as subtraction. It's negative 2. The coefficient of x is negative 2. So we have to divide by negative 2, and we have to divide by negative 2. So x equals 2. Here, the signs are going to be crossed together. I want you to think of it this way. Whenever we divide two negative numbers, the answer is positive. So negative 4 divided by negative 2, it's 2. And negative 2 divided by negative 2, it's 1. And we don't write the coefficient whenever it's 1. Now, I'm going to send the PowerPoint presentation for you, which includes the questions that you need to solve from the book and page numbers. So please try to solve them and send them back to me as soon as possible. You need to solve the questions on your notebooks. Thank you.